Calculating concentrations. First, some of the conversion of the key units. Oftentimes, we use milliliters and liters to measure the volume. In IB chemistry, centimeter cubed and decimeter cubed are used instead. 1 mil is 1 centimeter cubed and 1 liter is 1 decimeter cubed. Between 1 liter and 1 mil, it is a scale of 1,000, and so is it between decimeter cubed and centimeter cubed. For volumes, the progression between two neighboring units are usually 1,000 due to the cube existing between two different scales. Here are some terminologies. Solute means something that dissolves, like salt. Solvent means that something that does the dissolving, for example, water. Solution is a mixture. Okay, it's not a compound, it is a mixture of solutes and solvents. For example, salt water is one of them. So we don't really have a chemical formula for solution straight away. What we normally do is we will have the formula for the solute, and then we put what we use as solvent in states. Okay, so if we use water, and for salt water we use NaCl, so we know that's the solute, and then we put aqueous to stand for water. Okay. Molar concentration, it is a measure of the amount of solute in solution. I want to emphasize amount because we will put mole of solute in this unit. Molar concentration. Molar concentration, the formula for it is C equals to N over V. The concentration is usually calculated in unit mole over decimeter squared. So the amount of solute calculated in mole over volume of the solution, so everything together, in units of decimeter cubed. If we rearrange the formula to make mole the subject, we can easily find out the amount of solute in the particular solution. Here, mole stands for how many solute particles are present. Solute doesn't necessarily have to be solids. Volume of the solution, not just the solvent, and eventually the concentration is a molar concentration. Concentration in IB chemistry is often expressed in the square brackets. So for example, if we write square brackets around hydrogen cation, that means concentration of hydrogen cation in a particular solution. Now here's an example. Find the amount of solute in 100 centimeter of 0.100 mole decimeter cubed solution of NaCl. So all we need to do is to rearrange the concentration formula to make mole the subject, and therefore calculate the amount of solute in the solution. Notice that here we did a unit conversion to convert 100 centimeter cubed to something of a decimeter cubed. Hence, explain how you would prepare 100 centimeter cubed of 0.1 molar concentration of solution of NaCl. Now, here's the second part of the question. Hence, explain how you would prepare 100 centimeter cubed of 0.1 molar concentration of sodium chloride. If you remember when we talk about molar mass, we said that we cannot directly measure 0.01 mole, but we can weigh out the corresponding mass. So we need to first calculate the molar mass of sodium chloride based on our data book, and then we can work out the mass we actually need to weigh out on an electronic scale. Okay? So how we do that? Eventually in an experimental setting is we add 0.584 grams of sodium chloride, that's the amount that we have calculated, to a 100 ml volumetric flask, and we make up to the graduation mark with distilled water. Here, this is an example of the volumetric flask. This flask is solely made to make a standard solution. Here, the line is what we refer to as graduation line, or the mark that you're making up to. There's another way to measure concentration, parts per million, ppm. It is a mass over mass scale. So mass of component that you want to find out in a particular solution over the total mass of the solution. The good thing about this is that, first of all, both of the quantities that we want to calculate ppm are masses, and mass can be easily measured in an experimental setting. Parts per million is very useful in describing very low concentrations, such as found in air or water pollution. By the scale, a concentration of 1 ppm for a substance means that each kilogram of solution contains 1 milligram of solute. Okay. A sample of tap water was found to contain 0.0537 grams of sodium chloride per 250 grams of solution. Calculate the concentration of NaCl in parts per million. Based on the formula, we know that C equals to mass of solute over mass of solution and multiplied by a million. Okay. So here I want to emphasize that when you apply the ppm formula, you need to make sure that both the mass of solute and solution are measured in the same unit so that they can be cancelled in division. Dilution calculation. Now, the process of adding more solvent into the solution is called dilution. So when a solution is diluted, the solute particles are more widely spaced from here to here. Now, however, the amount of solute particles won't change. If you think about it, right? Before dilution, I have N1 amount of solute particles, and then afterwards I have N2 amount of solute particles. They eventually remain the same. All I did was adding solvent to the entire solution. And combine N1 equals N2 with the fact that N essentially equals to concentration times volume, then we have our dilution formula, which is C1V1 times C2V2. Now, here is another notation for this formula. Initial concentration times initial volume equals to final volume times final concentration. Now, let's see a practice problem. The concentration of C we extract in a bottle when it's concentrated was 9 mol per decimeter cubed. Then, when we actually use it on plants, we need to dilute it. So we took 10 mils of fertilizer, diluted to fill a 2-liter container. What will be the new concentration? So first of all, we have our initial concentration, 9 mol per liter, and then we have our initial volume, which is given as 10 mil of the fertilizer. Now here I'm converting 10 mils into decimeter cubed. I'd like to ask you to think about why I did that, okay? What are the implications? Why did I convert? Why didn't I convert it to some other units for volume? Then the final volume V2 will be 2 liters, and therefore we rearrange the equation. C2 will equal to C1V1 over V2. And as a result, we find the new concentration, which is much smaller, will be 0.045. Here's a summary of this session. The 2 units of concentration, mole per liter and parts per million. Mole per liter, which is amounting mole of solute per liter of solution, is also known as molarity. So sometimes if you hear people asking what's the molarity of this solution, we understand that they want the molar concentration of a particular solution. Then we introduce dilution formula, C1V1 equals to C2V2. When diluting, the overall solute remains the same, but the concentration decreases and the volume of the solution increases.